Welcome everyone. I'm Santosh Raikar, and today we're going to discuss the critical bridge between technology and results in industrial maintenance. We often talk about predictive analytics as a silver bullet, but this presentation is about the missing link, how we move from a digital alert to completed physical work. This is a board-level discussion designed to show how we convert those early warnings into tangible EBITDA, risk reduction, and organizational learning. To start, we have to address the core question that every board should be asking. Are we just buying flashy technology, or are we building an operating system that actually protects our value? We need to remember that predictive maintenance is essentially a failure if the alerts simply live and die on a dashboard without triggering action. Our main thesis today is that data visibility is not the same as executed reliability. A detected anomaly doesn't create value the moment it pops up. Value is only realized when the organization validates that signal, makes a decision, and completes the work safely. The missing link isn't usually the algorithm, it's the management and governance system behind it. Here's our roadmap for this session. We'll start by looking at why value leaks out after an alert, then dive into a robust alert-to-work operating model. We'll cover governance, CMMS integration, and how to translate these actions into financial terms. Finally, we'll wrap up with a maturity roadmap and the specific questions you should be asking your teams. Let's begin with part one, where we explore the value gap. Why is it that alerts don't automatically turn into reliability? We see a common failure pattern across the industry. The sensors work perfectly and the software generates a credible alert. However, that alert gets stuck in a loop of emails and discussions. Eventually, the asset fails, and the post-event review reveals that the system saw it coming. This is not a technical failure. It is a breakdown in organizational execution. We call this alert attrition. Every time an alert is handed off from one person to another, there's a chance for it to lose urgency or ownership. The ultimate business outcome depends entirely on what percentage of those alerts actually turn into verified work. As executives, you need to identify where these alerts are dropping out of your system. It's important to define what an alert actually is. It is evidence, not a finished decision. It's a prompt for human engineering judgment, not a guarantee that the machine will blow up in 5 minutes. An alert is only as valuable as the operating response it triggers before the consequence occurs. This is why so many pilots disappoint. On the technical side, everything looks great. The sensors are in, the models are trained, and the dashboards are pretty. But the operating system fails because there's no clear owner for triage, no rules for CMMS conversion, and no loop to learn from the results. You've built the engine, but forgot the transmission. Oftentimes, the real bottleneck is work execution capacity. A plant can generate alerts faster than the maintenance team can handle them. Without a way to rank risk, the queue just becomes noise. The highest value alert isn't necessarily the loudest one. It's the one that leads to the right action at the most critical time. Value leakage manifests as downtime, rushed repairs, and expensive expedited parts. This gap between potential and realized value is a governance problem. Boards should move away from asking about detection volume and start asking about realized value. Here is an executive insight to keep in mind. Predictive maintenance is not a dashboard. It is a closed-loop business process. The alert is just the starting line of the management system, not the end of the technical task. Now, in part two, let's look at the alert-to-work model itself, a closed loop that takes us from signal to verified value. This workflow is end-to-end: signal, judgment, work, verification, and learning. If any single step in this chain is weak, the value of even the best predictive model is erased. The role of the board is to govern this entire loop, not to micromanage the individual alerts. Step one is detecting the anomaly. This combines data with operating context. A good alert should clearly state what changed, where it happened, and what the potential consequence is. It should provide enough specific information to guide a human decision rather than just creating vague anxiety. Step two is validation. We need to separate real risk from sensor errors or normal process variations. Our experts should ask, does this signal make physical sense? The focus isn't just on whether the model is right, but whether there is enough evidence to justify changing our current course of action. Next, we must classify the alert by confidence and consequence. High confidence, high consequence alerts demand rapid action. Lower risks might just need a watch-and-learn approach. Having a clear matrix prevents us from overreacting to noise while ensuring we don't underreact to serious threats. Step 4 is creating a work order with full context. A generic instruction like check pump isn't enough. The work order needs to carry the evidence, the failure mode, and the urgency. We must preserve engineering knowledge so the technician knows exactly what they are looking for. Then we move to planning and kitting. The planner turns the alert into a scope of work with tools, parts, and permits. We need to reserve parts before the risk turns into an emergency. A credible alert without a plan is just a known risk that hasn't been mitigated yet. Scheduling must then align with production reality. Operations needs to help find the right window to perform the work. Not every alert requires an immediate shutdown, but none should wait indefinitely. The decision should be a balance of remaining useful life and operating risk. Execution quality is paramount. This is where we ensure the alert leads to avoided loss rather than a maintenance-induced failure. Precision is key here, following procedures and maintaining cleanliness. A predictive alert should lead to more discipline, not a rushed intervention. Step 8 is verification. Closing a work order isn't the same as returning an asset to health. We need to confirm that the indicators, vibration, temperature, pressure, have returned to normal. Without this step, we can't prove value or build trust in future alerts. Finally, we must learn and improve the model. We capture what was found and whether our prediction was correct. This feedback loop allows us to update our strategies and job plans, converting a single alert into a better system for the future. In Part 3, we address governance and decision rights. Who actually has the authority to move us from signal to action? Clear accountabilities are vital. If alert ownership belongs to everyone, it effectively belongs to no one. We need a simple RACI model that works during a busy production week, including who has the authority to accept the risk if work is deferred. It's helpful to distinguish between the alert owner and the asset owner. The alert owner, usually from engineering, validates the signal and recommends action. The asset owner, usually from operations, owns the production impact and approves the windows for work. They must work in tandem. Risk acceptance must be explicit. If we decide to defer a high-consequence alert, that decision needs to be recorded, along with who made it and why. Unrecorded deferrals create hidden enterprise risks that only become visible after a failure occurs. Governance operates at 3 rhythms: daily for urgent risks, weekly for planning, and monthly for chronic issues. For executives, the rhythm is quarterly, focusing on value realization and enterprise risk. This ensures that the system is functioning at every level of the organization. To be clear, boards shouldn't be managing individual alerts or bearing inspections. They should be governing the organization's capability to convert evidence into action. The board's focus should be: what risks are visible and what value are we protecting? Part 4 covers the integration with work management. This is where predictive maintenance becomes real maintenance. CMMS or EM integration is not optional. An alert must become a traceable object within the system that controls labor and materials. If alerts live outside your main maintenance system, they effectively don't exist in the eyes of the execution team. The work order itself must carry the intelligence. A weak conversion only gives a short description. A strong conversion identifies the specific component, attaches the evidence, and defines the risk priority. We want the technician to be fully informed before they arrive at the asset. Planning is what turns information into execution. A solid job plan includes the scope, tools, and safety requirements. The planner's job is to protect the technician from ambiguity and prevent the business from relying on improvisation. Response speed is determined by kitting and stores. Predictive maintenance buys us time, but that time is wasted if the parts aren't available when the window opens. Your store strategy must be an active part of your predictive maintenance value chain. Scheduling must respect both risk and production. We can't treat everything as urgent, or the system loses discipline. Conversely, If everything waits for a major outage, we lose the value of early detection. It's a delicate balance. We also need to watch out for latency. This is the time lost during diagnosis, decision-making, and parts readiness. An alert's value degrades over time. You should be measuring elapsed time at each step of the process, not just the final completion date. Finally, the technician is a critical validator. They aren't just following orders, they're confirming physical reality. Their feedback tells us if the model was accurate and if the job plan worked. The best systems make it easy for technicians to provide this vital feedback. Now we move to part 5, financial translation. How do we turn these technical alerts into EBITDA and cash flow? The value equation is simple. It's the avoided consequence minus the cost of the response. This includes everything from downtime and quality loss to safety exposure. Remember, the same alert has different financial value depending on whether the asset is a bottleneck or a redundant spare. Value cannot be claimed until it's verified. We need to move away from weak claims like "we caught a failure" towards strong claims that document confirmed failure modes, agreed upon consequences, and verified restoration of asset health. It's important to distinguish avoided loss from direct savings. Avoided loss claims should be conservative and transparent. Finance should be involved in defining these categories, so the program is seen as a legitimate business driver, not just a list of inflated stories. We should also prioritize alerts based on value. An alert on a bottleneck asset is a higher priority than one on a non-critical spare. Boards should be asking for value-weighted closure rates rather than just raw counts of how many alerts were generated. A board-level dashboard should show high-risk exposure and verified outcomes. The goal is to connect technology to business results. Ultimately, we want fewer surprises and better, data-driven decisions. In Part 6, we'll discuss KPIs and maturity. We need to measure closure, not just noise. A mature system focuses on verified learning. Model accuracy is useless if the work system can't respond to it. Therefore, we should measure maturity by how much risk is reduced and how much value is protected. Be careful with your KPIs. Useful metrics include the alert-to-work conversion rate and the time to triage. Misleading KPIs are things like total alerts generated or sensors installed. These measure activity, not effectiveness. We also have to manage false positives and negatives. False positives waste resources and erode trust, while false negatives lead to missed failures. A disciplined validation and learning process is the only way to manage this uncertainty. Human judgment remains essential. AI is great at pattern recognition, but industrial decisions require the context that only humans from operations, maintenance, and engineering can provide. The best decisions combine machine evidence with human experience. Trust is the foundation of the whole system. This means ensuring data quality and cybersecurity. If leaders don't trust the underlying data, they won't act on the alerts, and the whole work process will grind to a halt. To summarize this section, analytics is just one part of a larger operating system. The most successful organizations are those that govern the entire loop, from the initial data to the final learning step. That is how you achieve enterprise reliability. In Part 7, let's look at the implementation roadmap. How do we actually build this missing link? The rule of thumb is build the operating system first. Don't increase alert volume until your work process can absorb it. Start with one critical system, prove you can close the loop, and then scale across the enterprise. In the first 30 days, your goal is to map the leak points. Look at where alerts are currently getting stuck. Measure the time from generation to execution. Select one high-value area to serve as your pilot for a closed-loop system. During days 31 through 60, you define the decision rules. Build your triage matrix and clarify who has the authority to approve actions or accept risks. Set the standards for what a work order must contain to be effective. From days 61 to 90, you pilot the execution. Run regular alert reviews, convert them into kit work, and verify the results. This is where you capture technician findings to refine your models and strategies. In months 3 to 6, you start integrating systems. Connect your platforms to the CMMS, standardize your failure codes, and create dashboards that show closure and value. This is also when you train the broader team on the new process. Finally, In months 6 to 12, you scale the governance. Expand to other critical systems and utilities. Ensure everyone is using a common language for alerts and decisions so that you can learn at an enterprise level. Leadership needs to stop certain behaviors to succeed. Stop celebrating high alert volumes without closure. Stop treating this as just an IT project. Most importantly, stop letting credible alerts die in someone's inbox. Instead, start governing predictive maintenance as an end-to-end system. Measure verified closures, assign clear decision rights, and integrate your planning and scheduling teams into the workflow. This is how you translate technology into reliability. Part 8 concludes with some real-world vignettes and the questions you should be asking to see if your system is working. Consider this case. A compressor flags a bearing risk. Reliability sees it, but operations wants to wait. The bearing fails. The lesson here is that even a perfectly accurate alert is just an unmanaged risk if there isn't a clear decision owner. In another case, a pump alert correctly triggers a work order, but the parts aren't available. The plant has to run restricted until they can get expedited spares. This shows that predictive maintenance must be connected to your stores and planning strategy. In our third vignette, a repair is completed, but no one verifies it. The alert returns 2 weeks later because the failure mode wasn't actually fixed. We must remember, closing a work order is administrative, but verification is technical. As board members and leaders, here are 5 questions for your teams. Which alerts represent our highest risk? What percentage of alerts become verified work? Where's our process failing? Who accepts the risk of deferral? And what evidence proves we are protecting value? To simplify, stop asking how many sensors did we install, or how accurate is the dashboard. Start asking how many alerts became verified work, and how did our system learn and improve? These are the questions that drive real performance. In conclusion, predictive maintenance only creates value when alerts turn into disciplined action. The missing link is the work management system. By governing the entire loop, from evidence to completion, you can significantly reduce surprises and protect your enterprise's value. Thank you for your time. This presentation was prepared for professional development purposes. Please remember that all examples and metrics should be validated against your specific site data and engineering standards. I'm now open for any questions or further discussion.